Hello students, welcome back. In the previous video we did only the forward problems, so let's do a backward problem now. According to Center for Disease Control and Prevention, the mean height of 18-month-old American girls is about 80.2 centimeters and the standard deviation is about 2.70 centimeters. And we went through 3 problems and then this is the one I just added. Okay. And then let's go to 3.5 and 3.6. These are backward problems. Estimate the first quartile, estimate the third quartile, and of course I can find any other percentiles as well. But quartile is as good as any. So let's go ahead and do that. How do I do that? First, draw the picture. Outline, and then center. Where do I put end? It's first quartile, so it should be less. And this part should be 25%. Okay, from here, you have to find out the end. Previously, end was given as, say, 82 centimeters or 75 centimeters, kind of like that. But this time, no, I don't have the end. I have to find out. How do I do that? Let's go backward. From the table, find out the z-score associated to 25%. And then we are going to do this. Z is equal to end minus center over ST, which is end. I don't know what end is. And then the center is given as 80.2. And then standard deviation 2.70, and that is equivalent to something. I have to find out. Let's find out. That's associated to 25%. Okay, let's go. Well, okay, this is the table, and then left-hand side probability, shaded probability is 25%, so we have all these numbers, and let's find something that is closest to 25%, 0.25, and right here, 0.2514, 0.2483, they're pretty close, right? And the first one is associated to negative 0.67, and this one is associated to negative 0.68. And 0.2514 to 0.2583, pretty close. So the z-score I'm looking for must be somewhere in between, pretty much in the middle. So let me use negative 0.675. Negative 0.675. From here, we can solve for x. From here, just some algebra and you can solve for x. So x minus 80.2 is approximately equal to negative 0.675 times 2.70. If you flip over the denominator to the other side, you can punch in the calculator now, but I usually do it later. Flip this one over to the other side. Then we get x is approximately equal to 80.2 minus 0.675 times 2.70. Okay, this way I don't have to punch in twice. Just calculate it. And that's gonna be my first quartile. What do I get? 78.37 something, approximately speaking. So I'll estimate it as 78.4, approximately speaking. Well, I did not specify how many decimal digits to take, so it's free. But the given problem is using this first decimal digits, you see. The problem itself is using the first decimal digit, so I used the first decimal digit at the final answer as well. Anyway, that's how you find out percentiles. It's going backward. Same formula is used, but instead of calculating z-score from the end value, you look up the table to find out the z-score first and solve the equation to find out x value. Now, can you do the same thing and find out the 75th percentile? By the way, this is a problem. Yeah, okay. I use a little bit more precise calculator. Instead of negative 0.675, turns out 449. But come on, if you look up this table, then you're going to get about 0.5. And compared with what we got before, pretty much the same. Okay, how about the next problem here? Estimate the third quartile. Well, third quartile is 75th percentile, but it's not generally enough because we already did 25th and then 75th is, so let's go a bit more general. 85th percentile. I just made it up. Okay, alright. Let's find out 85th percentile. Oh, by the way, I just made up the problem. And okay, alright. And then the 80th percentile. Draw the picture, okay. And this is wrong picture because this is a picture just copied and pasted from the first quartile. I'm like for 25% here, but that's not what I want. I want 85th percentile. So a certain number to the left. Left shading is 85%. This is 50% in the middle, so I have to go quite a bit to the right around here so that all the way left is big, and then I have to the right only a small portion, just 15%. And here we go. This is a shading. So I'm looking for this, and then this is 85%, and by default, this part is 15%. All right, I'm looking for this end. How do you find it? The same deal. Z-score. Score is end minus center over SD. And in this particular case, end is unknown. X minus center 80.2, that's the mean. And the standard deviation is 2.7. And that should be equivalent to a certain z-score associated to about 85%. So let's go to the table again. Alright, this is a table, and the first page we have less than 50%. Let's go to the next page. More than 50%. And let's look for 85% here. Looks like this is a closet, 0.8508. Does everybody agree? 1.04, 1.0, and then second decimal digit is here. So 1.04. And there goes the equation that I have to solve. Not too bad. Just a routine algebra. Flip the denominator to the other side by multiplying out. So 8 minus 80.2 is approximately equal to 1.04 times 2.7. And flip this to 80.2 to the other side, and I get x is approximately equal to 80.2 plus 1.04, 1.04 times 2.7, and that's approximately equal to something, and let's do the computation. And what am I getting? I'm getting 83.008. So 83.01, let's say 83.0. Just take first decimal digit as a final answer. And what does it say? The 85th percentile is about 83 centimeters. That's for 18-month-old girls in United States. Okay, so, and then that's z-score is 1.04 approximately speaking, and then that's 1.04, and then that was 1.04, 1.04, and then 83.01. Okay, that's what we got before.